Hello, amazing people. This is David, and on this video, I'm going to be preparing you most certainly and accurately for your upcoming NECO Chemistry examinations in 2026. No matter how far away it is, I believe it's never too early to prepare. Thus, I'm making this video today. So if you're a candidate for the upcoming NECO examinations, this is one video you'd like to watch up until the end. So let's go ahead, get into what we have for today's video and see if we can learn a thing or two. The question on the screen right now starts off by saying a gas occupies a volume of 600 cm cube at a temperature of 27 degrees Celsius. What will the volume of the gas be at 127 degrees Celsius if the pressure remains constant? So the first thing to do would be to check out what topic or what platform this question is from. Now we can see from the question that a number of variables were talked about. The first one being volume and the second one being temperature. And it was said that the pressure remained constant. Now, the topic from which this question comes from would be the topic of gas laws because the question starts off by saying a gas. Now, the law that says or that relates the volume of a gas with the temperature of that gas when the pressure is kept constant is called Charles' law. Okay, and the expression of Charles' law says V1 divided by T1 is equal to V2 divided by T2. I have an entirely different video that goes into detail breaking down how this expression was arrived at. So go ahead and check out my YouTube channel to see what that video is. But this is the expression of what the Charles law is all about. So let's go ahead and solve this question. So we have V1 standing for initial temperature or initial volume, I beg your pardon, initial volume. And then we have T1 standing for initial temperature. And then we have V2 standing for final volume. And T2 standing for final temperature. So let's go ahead and impute our variables. V1, which is the initial volume. This question says a gas occupies a volume of 600 centimeter cube. So that becomes the initial volume, 600. T1. Now, you must note that temperature, as far as gas laws are concerned, are given in degrees Kelvin. And to calculate temperature in degree Kelvin, you add the temperature in Celsius plus 273. So it occupies a volume of 600 cm cube at 27 degrees Celsius. So the volume or the temperature this time becomes 27 plus 273. That gives us 300 degree Kelvin. So T1 becomes 300 Kelvin. Now V2, what will the volume of the gas be at 127 degrees Celsius? So the final volume is unknown. And then the final temperature is 127 degrees Celsius. So to calculate that in Kelvin, we have 127 plus 273. That gives us a total of 400 degree Kelvin. So imputing our variables into this question that we're solving right now gives us V1 over T1 equal to V2 all over T2. So let's impute our variables. V1 is 600 divided by T1, which is 300. This is equal to V2, which is unknown, divided by T2, which is 400. So when we cross multiply, we have a number of variables. So we have 600 multiplied by 400. That will be equal to 300 times V2. So allow me to clear up my screen a bit to have some space. 600 multiplied by 400, that gives us 240,000. 240,000. This is equal to 300 V2. So we divide both sides by the coefficient of V2, which is what we're looking for. So this becomes over 300, and then this is over 300 as well. This cancels this, so V2 becomes 240,000 divided by 300. That gives us 800 cm cube. The answer that corresponds most accurately to what we just got is option C, and that makes it the correct answer. I hope you got value for what we just did right now. If you did, please do well to like, share, and subscribe, because in this season, I'm going all out to ensure that you're most accurately prepared for your WAEC, NECO, and JAMB examinations. Do well to like, share, and subscribe one more time. And up until I see you in the next video, I remain David. Stay safe and God bless.